Hey everyone, and thank you for joining us today. I am Jennifer Joyce, Regional Vice President for Sales for the West here at Condusiv. And here with me today, I've got my partner in crime, Howard Butler. He is the Senior Director of Systems Engineering. Howard is actually a 30-year veteran of Condusiv, and he is an expert in the inner workings of the Windows operating system. So Howard, I'm really happy to have you here today. Thank you very much for joining me.
Hey, thanks very much, Jennifer. Always glad to be here. Hey, everyone, don't let her title fool you. Jennifer's been with the company for over a decade and is quite technical as well. So I think between the two of us, we're going to have a lot to say here today. But one quick housekeeping item is that we want to kind of keep this as an interactive webcast. So please drop your questions into the question box. And as we go along, we'll answer them right there on the spot, or we'll get to them as we go along during the Q&A session at the end.
Okay, great. Thank you very much, Howard, and really glad to have you here. I wanted to bring up one other housekeeping item real quick, how we're going to kind of organize the webinar today. We're going to do it in two parts. The first section I would refer to as kind of the executive briefing. We're just going to go over things pretty high level, talk about the use cases, the business benefits. We're going to show you real world examples of deployments benchmarked with third-party tools so you can really start to visualize what this software will do for you in your environment. Then for anyone who wants to drop off at that point, if you got it and you want to just try it, schedule a call with us, feel free. We are recording the session. We will send the entire recording out to everyone on the call, even if you drop off at that point. The second portion, for those of you who want to geek out with us, is going to be the technical briefing, where we really get under the hood, the nitty-gritty of exactly how we recover 40% plus throughput from your environment on just the existing hardware that you already have. So let's jump right into it. So the agenda here, we're really going to look at the use cases up front first. We've got 5 of them to show you, all real world, all benchmarked with third-party tools, and then we're going to go into that executive briefing that I mentioned. So let's talk a little bit about who Condusiv is. We're going to keep this pretty high level, get through this pretty quick, but it's always good to know who you're talking with. We are a 39-year-old software company. I think, Howard, we can probably round up and call it 40 soon, right? But what I've done here is kind of just try to look at some highlights, some of our street cred here. You can see what I like to call our scout badges: Microsoft Gold Partner, VMware TAP Partner, and this Microsoft SQL IO reliability certification was a really big deal. We're the only software publisher that has that. That's usually reserved just for the big hardware players, and you have to jump through a lot of hoops to get that certification. Also Citrix Ready certified, and you can see here kind of our flagship products. So we have got a lot of experience in this space, and we're going to enjoy talking with you about it today. So what I want to really focus on first is kind of, what's the stage of the environment here? We're all familiar with an S-curve of product adoption. We all know what that means. You get to over 90% and you're considered at maturity. But, things also fall out. The Model T Ford, some other technology here that we really don't see around unless maybe you're cleaning out a storage unit and you happen to find some archives. And just, we still have a lot of spinning disks around, but they're kind of at the top of the decline. We go into a lot of the technology that's in full maturity and full use right now. We've got the tiered storage, dedicated clients, all flash storage I would consider quite mature. Virtualization, 99% adoption at this point. The areas that we're still seeing a lot of growth: cloud, a lot of golf course conversations happening on this on the really large deployments, but not a lot of full actualization of that yet, still growing. We've got VDI, that's in an accelerated growth curve with what we've seen recently in the migration to home offices, and hyperconverged infrastructure. Now, the point of all of this is that the thing that's kind of the king of the hill at the top of all of this is Windows adoption. It is fully mature and it is everywhere. And it is delivered to the public in a large variety of platforms. We just went over what a lot of those are. It can be private cloud, public cloud, and any type of hardware. The main point here is that Windows is Windows, regardless of the environment that you host it in. And there's a major performance flaw that you experience no matter what hardware Windows is hosted in. It was really funny because this kind of was highlighted with one of my customers recently. We have a customer of ours, a hospital, that has us on about 350 servers. And they've got 4,000 VDI clients, and they were getting a consultation from one of their vendors who basically was talking with them about the fact that their throughput on their VDI needed to be improved to maintain peak performance for the users on that application. They said you can add hardware, or you could also assess everything in the image. Well, it was kind of ironic because the question the customer asked back to their vendor was, what can we do to improve this without having to add hardware? That was the answer, add hardware. The other thing they said was assess everything in the image. And they said, well, you guys built the image. You've put everything that's in there. What are we supposed to do with that? As the customer was kind of talking with me about this catch-22 situation, it crossed my mind. I laughed and I said, hey, isn't the Windows OS in the image? And he had to laugh with me on that one. And the reason it was funny is because he's already using our software on all the servers. He already knows that he got 30 to 40% plus throughput and performance improvement in his server environment by just simply optimizing the Windows OS. So we're able to take that same approach over to the Windows OS in his VDI context. Now, let's take a look at what this really looks like in the real world. This is our first use case. I'm going to just touch on this really briefly. Now, this is a chart with just some of the test results that we realized when we were doing our Citrix Ready certification, actually. These benchmarks were done with Iometer. We did these, in partnership with Citrix. And we did this on a Windows 10 system running Citrix XenDesktop VDA, both with and without the Condusiv product on it. And velocity, with it, the transaction rates increased by over 90%. And then we also look at the fact that we were able to get 60% more workload processed. And this is in the exact same amount of time with the exact same scripts running. It's quite an astounding difference. Now, what's behind this? There's two things I really want to focus on here right now, and these are the two IO myths. This is what I like to call the IOPS fallacy is the first one, all right? So the myth surrounding IOPS is that I have more than enough IOPS to handle the workload. Maybe I've got 30,000 IOPS, 100,000 IOPS. We had one customer come in and say, I've got an all-flash pure SAN with 600,000 IOPS. We're using a very small percentage of it, and we're still missing our SLAs. How could you possibly help us? So that really illustrates the situation. Now, the reality is that workloads on any hardware platform, whether it's spinning disk, hybrid storage, hyperconverged, in the cloud, all flash, those workloads are processing 30 to 40% slower than they should be. And the reason is sourced at Windows. Remember I mentioned Windows is Windows. Windows is creating a pattern when it issues the data that the application is sending to it. Windows then issues that IO in a very unhealthy pattern. It's small, it's split, and it gets randomized. That's very difficult to process. Sequential IO will always outperform random IO. So how can we solve that? We'll talk about that with the velocity solution and how we get that handled right inside the Windows OS with server-side optimization at the top of the stack. Now, the truth of the matter is, as I mentioned, only a small percentage of your total IO capacity is ever used at any one time. It gives us this, having this high IOPS rating, it really gives this false sense of security that we are maximized on our performance, especially with the second IO fallacy, which is the IO response time fallacy, which I'll talk about in just a second. Velocity focuses on optimizing the work that's actually being done, not the spare capacity that isn't being used. And I'll just give you a quick illustration of that. Let's say I walk into a room, I'm 5'3", and everyone around me is between 5 feet to 6'4". It's really crowded, and someone says, Jennifer, your goal is to get from one side of the room to the other as quickly as possible without touching anybody else. We're shoulder to shoulder in there. It's going to be very difficult for me to navigate that room. I'm going to be really slowed down in that effort. Now, picture the fact that this room has 20-foot ceilings. There's 15 feet of space above me, and that headroom is completely unusable by me. I have to focus on just the 5 to 6 feet of space in front of me that's actually being used. That's what velocity is going to do, is focus on that 5 to 6 feet of space that's actually being used by your hardware infrastructure to process the data. That's where your latency is, not with the headroom that's sitting there not used. So we're going to get you recovering that performance and throughput that you should be getting, and what we're going to be focusing on is transforming that small split random IO into large sequential contiguous IO, which is much easier to process. Now, that brings me to the second IO fallacy, and that's IO response time. Okay, IO response time by itself can be misleading. Flash is fantastic. Hyperconverged is fantastic. The faster we can process that IO, the better. The myth, however, is that faster IO response time is kind of the be-all, end-all. It is good, but it's not the only thing. Now, why I say it's a myth that faster IO response time alone is better is because you also want to take into consideration the nature of the IO, the size of the IO. If you've got a 4K block or a 64K block, the 4K block is by itself going to transfer faster just because it's smaller. We can dial up and down block sizes on your SAN and show you that. What it also doesn't take into account, though, is the IO split or is it contiguous? Is it random or is it sequential? So this starts to paint a much more rounded picture of what we want to look at. All of these pieces together contribute to your throughput potential, and that's what we really care about. Otherwise, we're really looking at a forest and a tree situation. The trees being the IO response time, your IOPS, the forest being your throughput. So the individual response time of each IO has been a bit over prioritized, and we really want to focus on getting that IO into a healthy IO profile. So we're going to hop into, with all of that set up, we're going to go ahead and hop into the second use case here. And Howard, this one I think would be great if you would do the honor of kind of presenting the data here. This is from actually a hospital. This one in particular was a VDI environment, I believe.
Sure, Jennifer, thanks very much. So let's take a quick look at what IO transformation with velocity can do. We're just going to go through these slides rather quickly. Feel free to drop any questions that you might have into the question box there. But the nice thing here is that we were able to validate this using third-party tools that you probably already have in your environment, like VROPS, which is what we used at this particular hospital. Now, the orange bar is the results with velocity. And as you can see, there's a pretty nice trend of improvement with the write requests per second. So let's go to the next slide, Jennifer. But wait a minute, what's up with this write latency? If this was the only metric that you looked at, you'd probably walk away thinking that velocity was slowing things down. And this ties back to what Jennifer was talking about in regards to that IO response time kind of myth. So let's see what happens with the next metric. Now wait, if we take a look here, write rate just shoots through the roof once velocity is enabled. And Jennifer, if I could ask you kind of to go back to the previous slide.
Sure.
Okay, so while looking at the write latency, sometimes the latency, I'll admit, is up to 3 times longer. But now if we go to the write rate again, go back to the next slide.
Yeah, got it.
Thanks, Jennifer. And on our throughput metric here, you can kind of see that the write rate improves anywhere between 2 to 6 times. So this kind of goes to show the power of focusing on the overall throughput of the data and not just getting hung up or over focusing on individual IO response time, because it truly is mostly about how much data can you push through the pipe. So now let's see what happens on the reads in the next slide. Okay, so here we get something very similar on the read latency. Looks like it got much longer, but let's take a look at what happens next. Now here, the read rate just kills it. It's off the chart. And if we go on to the next slide, Jennifer, I just want to throw one more metric in here on this use case, and that's disk usage. And I think the picture kind of speaks for itself. And let me just mention, this isn't about end user experience. Now, of course, it usually does boil down to that, but you have to step back for a moment and think about this on why would you have your virtual server and VDI density count set to the way it is today? It's because of end user experience. So when you install velocity, it really wouldn't be a fair comparison to go back and ask your users if they notice anything faster, because you've already set the stage, you've already optimized for the end game with the user to manage that end user experience by scaling down your density. But think of this, With velocity installed, you'll be able to scale it back up, increasing the number of virtual machines in that environment and still keep the user experience where it is today. And that truly can help, establish a longer lifespan of hardware and maybe get that extra year or more out of it. Now, Jennifer, if we go on to the next slide here, I just want to touch upon one more point here about how important this concept of IO transformation really is. And I'll go into this in greater detail kind of during the technical briefing portion of our event today. But just looking at this at a high level, to kind of sum it up, this is what we want to have happen to the right IOs. We take those split, small, random IOs and transform them into contiguous, larger, more sequential IOs. And that's really the key of getting back that 30 to 40% of additional throughput. Your hardware should be able to perform faster, but the way Windows is handling the data logically, it's kind of like Windows has its foot on the brake pedal of that high expensive, super fast Maserati you might have parked in the garage. So think of velocity as kind of pressing down on that accelerator pedal. Now, let's take a look at our next case. Now, I'm not going to spend a lot of time here on this one, but it is another Horizon environment running on a pure all-flash type storage array. And again, we tested this with measurements with VROMs. And these numbers are from a Fortune 500 company. In fact, it's one of those household cable companies that you would probably recognize. And this was a sampling from their call center. And as we can see here, the disk usage rate is significantly better, more than double in most cases. And if we go to the next slide here, commands per second, again, improve dramatically, more than double in most cases. And if we take a look at the next slide, we can see the average number of write requests. We can see that across the board, every system realized a significant increase in activity and throughput. And with the write rate, the kilobytes per second, this shows the average number of kilobytes written to the disk each second. And as we can see across the board, every system has realized a significant increase in productivity. And this would tie back to velocity, transforming those small split random IOs to contiguous sequential type data streams. And here we have the read rate in kilobytes per second. So we just looked at the write rate, now we're looking at the read rate. And this shows the average number of kilobytes read from the disk each second. Can't get that word out today. And as we can realize, a very significant increase in activity. Now here we have another case study, another hospital from their enterprise type servers. And I'll just kind of briefly go over this before we get to the technical briefing. But just to wrap this one up, one of the existing customers that we had worked with had just deployed to one of their tier 1 type of electronic medical records application. So this was isolated on its own host and clustered environment. They just recently expanded and added us to all 200 servers in their enterprise at once. And I'll just kind of mention something here. That kind of illustrates just how easy it is to deploy our software, either through using our included velocity management console, or you can certainly easily package it up and push it out with SCCM or other type of third-party tools. Simply run the setup or the MSI file, and guess what? It doesn't require any reboot. So you can push these out on the fly. Now, in this case, they deployed, like I said, to all 200 enterprise servers in one shot, kind of like a global deployment. And that's truly the only way, the only time you can measure before and after type of differences at the storage hardware level. Because the idea is that we want to optimize all the Windows VMs at once. And man, you'll be able to really see that universal IO transformation occurring. Now, we're pretty methodical when it comes to testing. If you take a look, these perfmon style type of counters are really what shows the most important part of performance, and that's throughput. And like I said, these were all collected with HPE InfoSight tools pointing straight at the Nimble storage array. So let's take a look at these numbers real quick on the next slide. Here you can see both max and average values of one particular server that was benchmarked from that Nimble storage type of perspective. Now, Nimble is a fantastic platform, love it. It provides incredible performance boosts, and every customer we've talked with who uses Nimble simply loves it. They rave about it. But most find throughput performance numbers a bit shocking. The reason we get this is not because of the hardware. The hardware is fine. It's operating as well as it can. The slowdown really is with Windows. Velocity fixes that problem right at the source, right inside of Windows. And if we take a quick look here from a second server in that same test group, again, I think these numbers and the graphs kind of speak for themselves. Okay, Jennifer, let's look at this last case coming up here. And here we have that final fifth case that we were talking about. This was tested on a load balance Citrix terminal server. They picked 10 systems to install Velocity on, and then they had a different set of 10 servers kind of used as a control group. And the customer tested using vSphere, sent the data back to us so we could analyze it. And the conclusion is that they would have a 32% improvement in reads and an 18% improvement on writes. So that kind of wraps up the use cases. And I hope this information has been really helpful. So Jennifer, I'm going to kind of turn the conversation back over to you.
Great. Thank you very much, Howard. I really appreciate that. And just a quick comment on this particular use case we were just looking at. And this is a way a lot of people start with us. They'll pick a particular application. So this client in particular already had us deployed on an 8-host SQL Server cluster to 32 SQL servers on that cluster. This was a secondary add-on testing they did. And they actually ended up getting 82 host licenses, and they're right now rolling it out to another 800 servers. So you really can see the momentum you get with what Velocity does in the IO transformation in an environment. So we'll just take a look real quick at, we're going to start transitioning into the technical portion. So we'll just wrap up with a couple quick benefits, how you test the software. Anyone who wants to hop off at that point, feel free, but we're going to take that deep dive into the technical right after that. So here, you can basically, it speaks for itself, the increased VM density, extended hardware life cycles, timeouts reducing, especially in the SQL environment, remote connections not dropping, things like that. We just hear it all the time. I'm not going to spend too much time on this slide right here. We're going to be sending the slide deck and the recording out. You can read this in more detail, but I'll just touch on the top one, Christus Health. They're deployed to over 2,200 VMs. We're able to literally a PO sitting on the CIO's desk for a $2 million hardware forklift upgrade was canceled, and they were able to keep that hardware stack in place for another 1.5 years. So, stuff like that definitely is kind of every day for Velocity. Our process to help you see if the product is going to be a good fit in your environment, we'll provide you with a free pre-POC consultation and a no-charge POC where you actually get to use the software, deploy it to as many Windows instances as you wish, and to really get that full experience with the product. And we'll also help you with the analysis and ROI business case, which is in fact, all of the previous use cases you just saw were excerpts from business cases that we helped existing customers and people who bought our software with. So that's the kind of output that we would help you provide as well to justify the purchase of Velocity. So it's a very streamlined and straightforward process that we can help you out with. We've got also a customized proof of concept plan that when we do our initial 15-30 minute consultation call, we will understand and assess your environment a bit better and then provide you with a written step-by-step plan so you know exactly what it's going to take. We usually wrap up proof of concepts in under 2 weeks. So we're going to hop into the technical briefing now. So let's get rolling on this. Now, this is really, I realize this is a rudimentary extraction of a virtualized environment. I think the main takeaway off this is that, you know, virtualization is fantastic. It's been around for a long time. It's been fantastic for server efficiency, cost efficiency, all of the above. But one of the biggest downsides to it is that virtualization really adds a lot of complexity to the data path. And that's what we've been talking about this whole time when we mentioned Windows, small split, random IO, a very difficult IO profile to process. And this is kind of what it looks like. Now we can go ahead and start optimizing. There's two different levels here, the Windows IO tax and the IO blender effect, which of course the Windows IO tax is that inefficiency from Windows we've been talking about. The IO blender effect is that problem with that data complexity from virtualization and really where the randomization comes into play and slows down that throughput. What we want to do is fix it. Now, you can take this approach. You can just deploy Velocity to a tier 1 key application that you really care about, but it's not going to address the IO blender effect. Real quick story on this. We have one of our customers that tested us on a six host cluster with 120 SQL servers. They were in this scenario. They had one workload committed to one customer that they were missing an SLA on. And that SLA, when they missed it, they had once a month to try to make this SLA. When they missed it, it was a $10,000 bill back off of their invoice to the customer. They had a $10,000 penalty every month. Very expensive SLA to be missing. And by the time they got to us, they had missed it every month for the previous year. They asked if they could go this approach. We said, you can, but it's not going to work. You're not going to make your SLA. What you really need to do is go to this approach. And the reason is because of the IO blender effect. So they tried it their way the first time. They just did that one VM. They missed the SLA. They then went to all 120 VMs. They made the SLA by 17 minutes. And we also asked them, they had very tight change control. It's a financial institution. We asked them to validate that we were the only major change made during the testing period, and they validated that we were the only change. They also validated that workloads had stayed consistent. So that's the power of the IO blender effect. Now, what we're going to look at is a little bit more of where Velocity sits and how it does this. So Velocity is a 100% software solution. There's no hardware component. There's no cards you need to throw into a host. It installs right inside the Windows OS. It is fenced by the Windows OS. And something to think about here is that because it's fenced by the Windows OS, and literally being installed in the Windows OS is the only place this optimization work can be done. We get asked a lot, hey, we've got Nimble's Castle, we've got, NetApp's Waffle, we've got all of these different technologies built into the hardware. Doesn't that take care of this problem? The answer is absolutely no, it does not. If you think about it this way, there are so many abstracted layers between storage and the OS. Storage is not able to talk directly to Windows and say, hey, Windows, would you mind sending me sequential large contiguous IO today instead of all that small split random IO you've been sending to me? I'd appreciate it, thanks. Could you get on that? That conversation is not happening, it's not possible. And if you think about it as well, there's not a flavor of Windows for VMware or a flavor of Windows for Hyper-V or a flavor of Windows for Nutanix or a flavor of Windows for EMC. Everybody else has to be compatible with Windows. Windows is calling the shots and it's telling everybody what drum to march to. So when Velocity gets installed, it's a filter level driver install, and we're able to actually optimize and transform the IO before it even gets issued. It's the only place you can do this. So being at the top of the stack is incredibly important because we are able to treat the source, not the symptoms. So it's compatible with everything as well because we're compatible with Windows and everybody else has to be too. Now, what we really want to focus on is Velocity and how we transform this IO, and it's applicable for VDI servers, for everything. What we really want to do is focus on two engines that we have in the product. There are many other engines, but the two we're going to talk about that actually do the optimization magic. One is the write optimization, and two is read optimization. Howard already alluded to our central console, which provides detailed reporting and also deployment and licensing management. Again, you can use your third-party SCCM or other deployment tools to manage the software as well. So we're going to jump into IntelliWrite, and IntelliWrite is the first major engine that we're going to talk about. Now, this is responsible for IO transformation that results in a reduction of a full 30% of the IO that Windows issues. So for example, if Windows was sending out and going to be writing a gig of data, now we've seen results from tens of thousands of servers, and we've done a lot of analysis. On average, it's about 134,000 to 157,000 IOs for 1 gig of data. I'm just going to call it 100K for simplicity. So if it took 100,000 IOs to write out 1 gig of data in a small split fractured pattern, if we can transform that IO before it's even issued, we can reduce that by a full 30%. So instead of taking 100,000 IOs, it will only take 70,000 IOs. And the very nature of those IOs have changed. They are now larger and they're sequential. And that is so key for that throughput, that fast performance. Think of it as a carpool lane. Now, Howard, I've touched on that real high level. Let me tap you on the shoulder. Is there anything else you want to add on to that on that engine before we go talk about the next engine?
Nothing more that I could really add to it unless there's some deeper questions that the audience has.
Okay. So if anyone's got questions, drop them into the chat box. We're going to roll into that next engine right now and give that a high level coverage as well. The second engine focuses on reads. And Howard, I did think of one thing to add on from the last slide, and that is when we're focusing on that write optimization and we've reduced 30% of the writes, when Windows goes to read that file back, guess what? It's going to read it back also in that new pattern. So if it's 30% fewer writes, it's also by halo effect, 30% fewer reads. Now we have a secondary read optimization, and this one's very active. This is DRAM read caching. And it is very unique. There's a lot of caching strategies out there. The reason Velocities is so unique and is so effective is because of the way it's designed. Now, I think that the real genius of this engine is that it is completely dynamic. And we've got the next slide, we'll talk about the dynamic utilization of that memory. And Howard, I think I'll ask you to talk about that a little bit more. So not only are we using the memory dynamically, we also leave at all times what I like to call a starting line of memory free at all times. So even though we're using a portion, borrowing a portion of that memory, we never trick the system into thinking that it's into a memory starvation situation. And Howard, let me actually, I think you're a little bit more knowledgeable about this than I. Would you talk a little bit about the intelligence of what we're caching? What we select to put into that cache?
Sure. So the concept of caching, I mean, you really have to think about it that you can't cache everything, nor would we really want to. It would just take an ungodly amount of system resources. We recognize that memory is of perhaps limited supply, and we really want to make the best use of it. So what we're able to do is identify the actual behavior of your application at this particular moment in time and recognize what data blocks are being read over and over and over again. What are the most frequently accessed data blocks? And are those the ones that are kind of gumming up the works? Are those the ones that are just throwing the storage into kind of a tizzy? So if we can satisfy those repetitive reads, those are the hot ones, those are the ones that are frequently occurring, and satisfy those directly from memory, you get memory-to-memory data transfers, which are many times faster than going to flash or SSD or spinning disks, and it alleviates or eliminates that amount of chewed up bandwidth that the storage system could spend doing other useful things. So we're really particular about what we want to put into cache, and it will stay in the cache so long as it's a frequently accessed segment of data. Over the course of time, we're able to increment the importance of that entry in the cache based upon how frequently it's being used, but applications do kind of shift gears and change around. So when data that was in the cache or still is in the cache is now no longer as hot as it used to be, there's likely the chance that other data that is now being read should be added into the cache. So we can dynamically source or put what we want into cache based upon the actual dynamic behavior of your applications. And the great thing about this, you don't need any tools to figure it out. It's all automatic.
Thanks, Howard. So I brought up this next slide for you as well, if you might touch on this a little bit,
Sure.
just to, kind of explain to folks how we really stay out of the way, how, especially SQL, things like that, how we are not going to have Windows thinking it's starving for memory.
Exactly. So this is a great animation, kind of a visual on how Velocity is able to dynamically adjust its memory usage, only using memory that's free, available. It's memory that would otherwise be idle and unused. Okay, so we have the intelligence to be able to know when there is a demand for memory, and when that occurs, we can then release memory from our cache, give that back to Windows. So there really is never going to be a shortage of free memory that would tend to cause Windows to become kind of in a panic mode. This keeps Windows and other applications quite happy. So you can kind of see how it dynamically fluctuates up and down, but always keeping a certain amount of memory free and available, and then just adjust itself accordingly based upon what's free, what's available, what's in use, and what kind of benefit we can provide.
Yeah, and speaking of that, Howard, the benefit, and guys, just a quick housekeeping thing. We've only got 2 slides left. We're on the home stretch, so we'll be wrapping up shortly with the final comments here. But on that benefit side, what all this means with this engine, we talked about the IntelliWrite engine. And what the IntelliWrite engine is doing is that streamlining of I/O, reducing 30% of the writes, and subsequently, just by halo effect, 30% of the reads, because it's all sequential now. This engine caches and reduces another 20 to 30% of all of the small, noisy, tiny I/O read traffic. This engine is a monster. It provides an incredible benefit. And Howard, I think you might have touched on this, but when we're doing this DRAM read caching, it's common knowledge, memory to memory data transfers are going to be 12 to 15 times faster than even going down to reading from an all flash layer. And moreover, you're removing all of that IO from the ecosystem. So you're serving it, just server side optimization and clearing out that 5 feet of space that is being used. You're getting this out of the way so that the rest of the IO that is now transformed in sequential can go even faster. And as you saw on the use cases that we presented today, we're saying 30 to 40% throughput improvement. Guys, you saw on the real world numbers that it was way more than that in most cases. So we're being conservative when we're talking about that. So the last couple concepts here, I'm not going to spend a lot of time on this one. This is just actually a document directly from VMware, their vSphere monitoring and performance guide, disk IO performance enhancement advice. They have two comments here. The first one is, hey, make sure you got enough virtual machine memory to allow the OS to cache and offload IO directly from memory. Well, we already have plenty of memory on servers, and we all know that the OS is not going to be doing any more caching than it already is. So we're taking that recommendation and putting it on steroids with the Velocity and telememory recommendation. Number 2, defragment the file system on all guests. Nobody's defragmenting today. We all know it needs to be done, but no one's going to do it in a virtualized space where if you do a big defrag on all of your servers, you're going to have a huge IO storm. Everything's going to move. You're going to balloon your snapshots and your backups because all the data moved around is just not going to happen. What we've done is we've come in and we've completely eliminated the need to defragment. Think about it. What we've done is if you take kind of maybe a child's tale of the egg on the wall, it breaks. A lot of work to come and put that thing back together. That's the defragmentation world. What Velocity has done is it doesn't let the egg fall and break in the first place. So you keep the files large, sequential, contiguous as they should have been natively. So that's what we're all about, and just really helping that disk IO performance and just bringing that to fruition in reality. This is what our UI looks like. It's going to give you, this is one of the screens. There's a lot of other reports in there that go into a lot of details. This is another report. You can see server by server level information. So that's it, guys. We're going to wrap this up. And this is our contact information. We will have one of our team members reach out to each and every one of you to schedule your free consultation. The goal of the consultation is to see if your environment is a good fit for Velocity or not, and let you know what's involved in doing the free POC. It's a very easy, quick, simple process. No reboot required to install the software and test it. And we'll be happy to help you out. We really look forward to talking with you. I don't see any questions in the question box. So Howard, I think we're going to go ahead and wrap it up. And I wanted to thank you very much for attending today.
All right. Well, thank you very much, Jennifer. My pleasure.